And then now we'll focus on the inclined problems. But first, I'll give a basic introduction and then gonna derive the formula. Let's say mornally an incline, whereby mornally an object on this incline. Relaure mornally angle. So now let's see mornally many cases. This object, it can be pulled upwards and then yeah in this direction. Finally, another case whereby this object, it can be pulled at an angle, but still it will be in this direction. Finally, another case whereby there is no force applied on this object, whereby this object it will be a slider. There is no force applied and then this object is slider. This is due to gravity. Finally, a normal force here. Remember a normal force always acts perpendicular to the surface. This is our surface. Normal force it will in this way or create 90 degrees. So I can say mornally a normal force. Another thing again gravity always acts downwards on the object. Our gravity is in this way, which is our weight force. So more the gravity, which is the weight force. Mg. Remember W mg. So ke tlo name mg. It's important to know always an incline. Always this weight force you are broken down into two components. Probably these components. So this is a component and then probably another component in this way. Now we can a right angle triangle. And then this is 90 degrees. It's important to understand this angle theta this angle. Let's see why ke re dialekana. Ge o ka lebelela this right angle triangle, this is 90 degrees. Let's just say for example this angle theta ke 30 degrees. This angle you ba 60 degrees, because the sum of interior angles to triangle the add up to 108. This is 30 and this is 90, 120, and then the remaining angle must be 60. So this is 60 degrees. And then now this line is perpendicular to this line. Create 90 degrees. So this must be 90 degrees. And for the reason this is 60 degrees, this remaining angle must be 30 degrees, because 60 plus 30 is 90. So this is indeed 30 degrees. This is true, and this is 30 degrees. This angle and this angle dialekana. So that is something very important. So now kinyaka this right angle triangle and then derive some formulas. Here. Mornally angle which is theta. And then this hypotenuse, remember relate mg. So more mg. And then let's say this force x, and then let's say this one y. This one y, and then this one x. So muginale x and then muginale y. So now ke nyaka gore re find the x and y in terms of mg. Re tlo shumisha a trig ratio. Ke tlo re sin theta e lekana le opposite over hypotenuse. So re la gore ke na le x over mg. So now ke nyaka go find x. Re la gore ke tlo cross multiply. So x e lekana le mg sin theta. So re la gore now nka dira conclusion ka re this is mg sin theta ke this force. And then now let's find your y. Ke tlo dira the same thing ka shumisha trig ratio. Ke tlo re cos theta e lekana le adjacent, which is y, and then hypotenuse ke mg. So now re la gore y e lekana le mg cos theta. So this is mg cos theta ke this force. This force re bitša gore ke fg parallel. So this one re bitša gore ke fg parallel because go kgona bona gore e parallel to this slope. So re bitša gore ke fg parallel. So re la gore mo re na le fg parallel e lekana le mg sin theta. And then this one re bitša gore ke fg perpendicular because o ka kgona bona gore e perpendicular to the incline. So re tlo re ke fg perpendicular e lekana le mg cos theta. And then another thing that is very important gore this fn e lekana le this mg perpendicular. Let's understand why. This box is either here down or here in this direction. So for the reason here this box ga e in this direction and then ga e in this direction, re la gore these forces must be balanced. Re la gore di a lekana. Let's say for example, ge le gore this is you and your friend, and then let's say when I push out your friend in this direction, and then Liana or pusher in the opposite direction. Gaylor wena mo pusha ka force ya 50 newtons, and then Liana or pusha ka 50 newtons. Erela ore lo remain stationary, le tlo no ema on the same place. A gona wa ka ya ka left, ibila gona lo ka ya ka right, because the force still not balanced. So more na le a similar situation. For the reason ya ore this object ga e in this direction, ibile ga e in this direction. Rela gore these forces must be balanced. So rela gore di a lekana. Therefore rela gore in conclusion ke tlo re fn e lekana le fg perpendicular, and then fg perpendicular le lekana le mg cos theta. So this is a very important formula. O tlo tshwanela go tsebe gore always ge re dila le the incline, ge re nyaka normal force, re tla ba re shumisha this formula. Another thing again gore this force re bitša gore ke fg parallel. The reason re bitša gore ke fg parallel, o ka kgona bona gore is parallel to this force. Remember gore this force re biditše gore ke fg parallel because really a parallel to the slope. Rela gore even this one must be parallel to the slope and then also parallel to this one. So rela gore this is fg parallel. Now another thing to know gore this fg perpendicular ke yona e dira gore this object e remain on the incline, because otherwise this box e betla dula on the air. So this force ke yona e goga gore e be on the incline. And then ge this object e ya fase o sena force applied, this is because of this fg parallel ke yona e gogela go fase. So now re la gore re na le this formula ya normal force and then re na le fg parallel. Re question ya go tseba gore what is the force e le gore e pusha this object or e downwards, re tlo shumisha this formula. And then this one ke normal force, or you can say Fg perpendicular. In the exam they will never say derive this formula. Nna be ke di derive for the sake of understanding gore why re tshwanetse re shumishe these formulas, and then lay some other problems. So now re lebelle some practice problems. This one is a crate of mass 10 kilograms slides down a slope inclined at 60 degrees to the horizontal. The coefficient of kinetic friction between the crate and the surface of the slope is 0.4. More than an object. And then what would you this crate is fast. For the reason ya slider, there is no force applied. This crate is fast due to gravity. And then this is Fg parallel. This object is slider in this direction. And then now it means the friction is in the opposite direction. So actually move the frictional force. The reason the frictional force is because the coefficient of kinetic friction. So a frictional force. So first re draw a free body diagram. Always a weight force is acting downwards on the object. So it's Fg, or you can say weight. It's all up to you. And then more Fg parallel, because this object here first. And then a frictional force is acting in the opposite direction. And then a normal force. Remember normal force always act perpendicular to the surface. This is our surface, normal force in this direction. So this is our free body diagram. This question in part A. This question calculate the magnitude of the frictional force. This is our formula to calculate a frictional force. For the previous video, this formula. Coefficient of friction and then times the normal force. The coefficient of friction, which is 0.4, but normal force. So create normal force first. But remember more the incline. To find the normal force, Fg perpendicular. So this is the same as saying normal force Fg perpendicular. And then Fg perpendicular mg cos theta. So from there I can substitute 0.4, and then mass 10 kilograms, and then gravity, which is 9.8, angle 60 degrees. So it will fall 19.6 newtons. So this is our frictional force. So now our level part B question. Part B, calculate the magnitude of the crate acting down the slope. This object or force is due to this force. So Fg parallel mg sin theta. And then from there it's all about substitution. So mass is 10 kilograms. This is 9.8, and then angle 60 degrees. And then 84.87 newtons. So this is our Fg parallel. The next question. this one a block of mass 10 kilograms is released from rest on a rough inclined to the horizontal at an angle of 30 degrees. The coefficient of friction is 0.5. Find the acceleration of the block. Mo re a block yellow is sliding down. This is because Barbudijore is released from rest. And the moment Barbudijore is released from rest, there is no force applied. So this object is slider. And then slider this is due to this FG parallel. And then mo Barbudijore a rough slope. Ge ba ka go botša gore o na le a rough slope o rela gore o na le frictional force, but ge ba ka go botša gore o na le a smooth slope rela gore there is no frictional force. And then again, for the reason ya gore ba file the coefficient of friction rela gore indeed re na le a frictional force. So now re draw here a free body diagram first. Re na le the weight force, which is downwards, and then Arnali FG parallel in this direction, and then Rabali frictional force. Remember a frictional force is opposite to the direction. This object here first a lot of friction over in this way, and then Arnali a normal force. Right, or always act perpendicular to the surface. So now we're level this question, you'll find out the acceleration. In the previous video, we find out the acceleration. We shumisha this formula ya Newton's second law. More acceleration, and then this one ke mass rnaluon. But our level this part ya F net. Let's about F net the vector sum of all forces acting parallel to the direction of motion. Object here now in this direction. This is our surface. Only the forces the parallel to this surface. Frictional force le this FG parallel, because Fn parallel to the direction of motion. This is Fn, they are not parallel. So for F net, we substitute a frictional force, and then we substitute a gravitational force. And then remember, always the direction of motion is positive. The force they are in this direction is positive. FG parallel, downwards in the direction of motion. Positive. But because friction here in the opposite direction, negative. So for F net, get FG parallel, and then got minus frictional force. More negative frictional force because the opposite direction. This one is positive because here in the direction of motion. But first degree this frictional force because so let's find the friction. Let's about a friction coefficient of friction and then times normal force. For the reason ya the incline, the normal force FG perpendicular, which is mg cos theta. So now let's substitute. 0.5 ya coefficient of friction, and then mass 10 kilograms, 9.8, and then our angle now 30 degrees. So from there, I press this part calculator, the answer to 42.435 newtons. So now because a friction, FG parallel, and then from there ke gonna solve for acceleration. So from there ke tlo re mg sine theta, remember our FG parallel le kana le mg sine theta, and then minus friction and then equal to ma. So mass get 10, and then this is 9.8, and then sine 30 degrees minus this friction rena le yona re kry-ile gore ke 42.35, and then equal to ma, and then this is 10, and then re nyaka acceleration, and then ge o ka pressa this part ka calculator e tlo fa gore ke 6.565. But it's very advisable or in the exam o ska round off during the calculation or round off the final answer. So anyway, re tlo nyaka acceleration re la gore ro divide both sides ka 10. So re la gore acceleration yo re fa gore ke 0.66 meters per square seconds. So this is our answer. Re lebelle the next one. And then this one here, a 4 kilogram block is pulled along a frictionless incline by a constant force F acting parallel to the incline. The block moves at a constant velocity. More, this object gona le a force applied. This object ba go godimo ka this force F. But mo ba re boditse gore ga re nne a friction because Varile is being pulled up along a frictionless incline. So we don't have the frictional force. And then this object move at constant velocity. So this is something very important. So now our level this question. Recalculate the magnitude of the perpendicular component of the weight of the block. First, I draw here a free body diagram. Can I lay this situation? Where this block is being pulled up, rela or wanna lay force applied, but this time around o ka kgona bona gore ya up, so more na lay force applied, and then obvious rena lay a weight force which is always downwards, and then rena lay a normal force in this direction. So free body diagram ke tlo ngola in this way. Ga ke tlo add FG parallel for now because this object is being pulled upwards. We ke tla add this object is going downwards. So this is our free body diagram, and then our level this question. This question in nyaka calculate the perpendicular component. Re tseba gore the perpendicular component ba bolela ka this one, and then re tseba gore ke FG perpendicular, and then FG perpendicular re tseba gore le kana le mg cos theta. So from there, finding the perpendicular component ke tlo re FG perpendicular le kana le mg cos theta. So ke na le 4 as a mass, and then the angle is 30 degrees. So it will favor ke 33.95 newtons. So this is our perpendicular component. And then now our level part B question. For part B question, re nyaka go calculate the force because this object is being pulled up. Re la gore ba pusha ka a certain force. So re nyaka that force. Ke tlo dira in this way. Ke tlo shumisha the fact ya gore ke na le the constant velocity. Ke tlo re F net ele kana le ma, and then for the reason ya gore ba this object is tsamaya the constant velocity, re la gore our acceleration is 0. So re la gore actually mo ke na le F net equal to 0. The reason ke nyaka go shumisha this fnet ke tseba gore fnet it consists of all the forces tše already actor in this. So re la gore le this f ke part ya fnet, then re la gore at some point nka kgona go ba le f. So that is why ke choositše this fnet formula, and then ka lemoga again gore ba mfile gore this object is tsamaya at the constant velocity. So now let's see something. Ge lo re o na le object in this case, and then let's say this object in a frictional force, and then let's say this is force applied, and then more na le normal force, and then more na le gravity. Ge ba ka botša gore the object is tsamaya at the constant velocity, ba re botša gore the fnet is 0. Ge ba re the fnet is 0, ba no re botša gore all forces are balanced. E rela gore the upward forces di a lekana, and then again these horizontal forces di a lekana. This is because ge re re fnet equal to 0, a re lebelele this example. Re tseba gore ge re nyaka go calculate fnet re šomiša this example, e rela gore ro substitute ka this force and this force, and for the fact ya gore ba re this is 0, it means ge ke yo adda this force and this force, it means ke tlo tshwanela gore ke kreye 0, because ba rile fnet e lekana le 0. The only time nka kreyago 0 is if this force and this force di a lekana, but the only difference is over a negative sign, because ge lo re this is 5 and this is minus 5, e rela gore 5 minus 5 e fa 0. So re la gore in other words, let's say this is 5 and this is minus 5, re la gore I'll be having 5 minus 5 and then equal to 0. From there I can say 5 e lekana le 5. So that is why ke re la gore these forces are balanced. So re la gore in conclusion I can say a force applied e lekana le frictional force. Ke bontšitše example here. So tshwanetse o tsebe gore always ba botša gore the object is tsamaya the constant velocity, e rela gore the forces are balanced. So now let's see based on this question. So e rela gore this force and this force they are balanced, and then this force and this force they are also balanced. E rela gore the forces ja the same dimension, they are all equal. E rela gore this force and this force di a lekana, and this force and this force di a lekana. So from there e rela gore I will say this f ke f e re nyakago, ke tlo re e lekana le this f, which is fg parallel. So re la gore lekana le fg parallel. So it really makes sense, because ge le gore fnet equal to 0, re la gore this force and this force must be equal. And then from there, because ke nyaka this f, re la gore is all about finding fg parallel. So re la gore from there I will say f e lekana le mg sin theta. So re la gore mo ke na le 4 and then ke na le 9.8 and then sin 30 degrees. So the answer to fa gore ke 19.6 newtons. So this is the magnitude f, ke this one. So it's very important to tsebe gore always ge le gore the fnet is 0, e rela gore the forces are balanced. E rela gore this force and this force di a lekana, this force and this force le tsona di a lekana. So but because now re na re be re nyaka this f, so that is why ke no re f e lekana le fg parallel. So this is our answer anyway. This one here, a car is at rest on a 15 degrees incline. If the mass of the car is 1000 kilogram, mo rena a car that is at rest, meaning it's not moving, and for the fact that this car is not moving, the acceleration is 0. And then if the acceleration is 0, re la gore F net equal to 0. And then ge e le gore F net equal to 0 e no re la gore all forces are balanced. Actually re na le this situation, re tseba gore FG parallel e acta in this direction. E try go pusha this object or e downwards, but it happens gore go na le a friction. Re tseba friction always opposes the direction of motion. So this friction le this FG di na le the same forces, so that is why this object e remain stationary. E ka se ye in this direction ebile e ka se ye in this direction because these forces di a lekana. So a re lebelle this question part A. Recalculate the magnitude of the frictional force. O ka kgona bona gore e straightforward because re tseba gore this force and this force di a lekana. From there e re la gore ke tlo re a frictional force e lekana le FG parallel, and then re tseba gore FG parallel le lekana le mg sin theta, and then mass ke 1000, and then angle ya rena ke 15 degrees. So from there re la gore the frictional force yo re fa 2536.43 newtons. So this is the frictional force. So now re lebelle part B question. Part B e re calculate the coefficient of the frictional force. Ke tlo dira in this way. Ke tlo re frictional force e lekana le the coefficient of friction and then times the normal force. The reason ke shumisha this formula is because ke tseba gore the only way nka kgona go kry-a the coefficient of friction ke ge nka shumisha this formula. And then now let's substitute. Re na le the friction re kry-ile gore ke 2536 and then 0.43, and then this is the normal force. For the reason ya gore re dila le the incline, re tseba gore normal force e lekana le mg cos theta. And then now let's substitute. Mass ke 1000, and then this is 9.8, and then cos 15 degrees. So now because re nyaka solve the coefficient of friction, re la gore re tlo divide both sides ka this part, and then re ka divide both sides ka yone re la gore your coefficient of friction e tlo fa gore ke 0.3. So this is our answer. It's not difficult at all because what is important ke gore o kwešiše question e nyaka eng. So that's it for this problem. This one here, a car's engine applies a force of 5200 newtons to keep the car moving up the incline at a constant speed. The car has a mass of 1200 kilograms and the frictional force acting on the car while moving up the incline is 1800 newtons. More normally, a car yellow is moving up the incline, and then the force applied to 5200 newtons. Normally, a frictional force yellow is acting in the opposite direction. Actually, more normally this situation. Normally, force applied in this direction, and then normally frictional force, and then again normally FG parallel, because that's about FG parallel always a pillar in this direction. First, I draw a free body diagram. Normally a weight force which is always downwards, and then more normally a force applied, and then more na le friction, and then this is a normal force. But ke nyaka o lemoge gore ge ke draw here this free body diagram ga ke include this FG parallel. The only time re include this FG parallel ke ge e le gore this object ya slider. Remember gore the purpose ya this FG parallel ko go dira gore this object is slide. So ge e le gore this object ga e down on the FG parallel, e rela gore ge re draw ya a free body diagram ga re include. But we are not saying ga re ne FG parallel. So anyway, a re lebelele this question. Calculate the magnitude of the car's weight acting down the slope. Acting down the slope. E rela gore actually re nyaka FG parallel, because re tseba gore FG parallel ke a force e le gore is always acting down the slope. Ke yone cause gore this object e ye fase, but due to this force applied e ka se kgone go ya fase. So now let's find that FG parallel. What we know gore FG parallel e lekana le mg sin theta, but lemoga gore ga re ne angle theta, because ga se ba re fe angle theta here. It means re ka se kgone go šomiša this formula. E rela gore now ke tlo tshwanela gore ke šomiše the Fnet formula. Ra tseba gore Fnet e lekana le ma. The reason ke šomiša this Fnet ke tseba gore Fnet e tshwere all forces, so rela gore nka kgona go finda le Fg. Fnet ke the vector sum of all forces. Remember, re nyaka only forces tše le gore di acta in the direction of motion, tše le gore di parallel to this line. O ka kgona bona gore ke force applied, ke Fg parallel, and then ke frictional force. But lemoga gore this object e ya upwards, and then for the reason ya gore ya upwards, e rela gore the forces tše le gore tšona di upwards ya ba positive, and then tše le gore di in the opposite direction ya ba negative. So rela gore force applied ya ba positive, and then these two forces di ba negative. So rela gore mo ko ba le force applied, and then is positive, and then got minus Fg parallel, and then got minus a frictional force, and then got equals to 0. The reason ke re ke 0 is because ba re boditše gore this object e tsamaya at the constant speed. Ge ba re e tsamaya at the constant speed, e tshwana le ge ba re e tsamaya at the constant velocity. Remember gore actually the speed and the velocity is the same thing. The only difference is gore speed is a scalar quantity, and then velocity is a vector quantity. Speed has no direction, but a velocity in a direction. So actually it's the same thing. It's only this object is at the constant velocity. Remember for the previous examples, really this object is at the constant velocity. The Fnet is 0. Therefore these forces are balanced. This is true. These forces and these forces they are lekana. Ge o rata o ka dira in this way, just on tshwana for the previous examples. The force tše le gore di acta in this direction ke Fg parallel, and then le friction, and then ra re di lekana le force applied, because really these forces and these forces they are balanced, because Fnet is 0. This is actually the same as this one, because let's say o tšea this Fg parallel we share to the other side, e rela gore ka mo o tlo ba le 0, and then o na le force applied, and then minus Fg parallel, and then minus a frictional force. So ka kgona bona gore actually it's all the same thing. This is negative, and this is positive. It's all the same thing. Don't be surprised that now ke šomišitše in this way, and then worry because in the previous ke tlhalositse gore ge ile gore the F net is 0 e rela gore the forces are balanced. This is true, the forces are balanced. E rela gore these forces di lekana le these forces. So anyway, now let's substitute. Force applied ba re file yona gore ke 5200, and then re nyaka FG parallel. Re na le friction gore ke 1800. So from there e rela gore ke tlo re 5200 minus 1800, and then e re fa gore ke 3400. Ke tlo tšea this FG ke isha to the other side. So re la gore re kry-ile FG parallel, and then re la gore ke 3400 newtons. So this is our answer. Part B e re calculate the angle of the incline. Ke tlo dira in this way. Ke a tseba gore FG parallel e lekana le mg sin theta. So ke tlo calculate this angle. From there re la gore ke na le FG parallel gore ke 3400, and then the mass ke 1200, and then gravity is 9.8 times sin theta. So from there in our maths re la gore this is the same as dividing both sides ka this part first. Re la gore actually ke tlo re sin theta e lekana le 3400, and then divide by 1200, and then 9.8. So from there, because re nyaka angle theta, re la gore re tlo find out the inverse using the calculator. Ra shift sin this part, and then from there re la gore angle theta e re fa gore ke 16.81. So this is our angle. Part C e re calculate the coefficient of kinetic friction between the car and the slope. Ke tlo shumisha this formula ya friction because e na le coefficient of friction, but ga re ne normal force re la gore re tlo find a normal force, but remember normal force e lekana le mg cos theta. So now re tlo substitute this fk re na le yona e re file gore ke 3400 ke frictional force, and then re na re nyaka this coefficient of friction, and then mass ke 1200, and then gravity ke 9.8, and then angle re na le yona re kry-ile gore ke 16.81. And then from there, because re nyaka the coefficient of friction, re la gore re tlo divide both sides ka this part, and then ge o ka divide ka yona re la gore our answer e re fa gore ke 0.30. So this is our coefficient of friction, and that's it for this question. This one re an object is pulled up an incline angled 30 degrees to the horizontal. An applied force of 600 newtons acts at an angle of 20 degrees to the incline and causes the object to accelerate at 4.62 meters per square seconds. Calculate the frictional force. Morally, an object is being pulled at an angle. What is important generally an object is being pulled at an angle. This force you create the components. Morally a vertical component, and then morally a horizontal component. Erelaure is in this direction because this object is in this direction. On this statement, azanga barbuja a frictional force, but question calculate frictional force. Erelaure there is a frictional force, and then based on this drawing, mobar bonchiji a frictional force. First, draw a free body diagram. Arnali a weight force. and then re a frictional force in this direction because object erna iya up the incline. Re a normal force is perpendicular to the surface. This time around, a force applied to is in this direction. Remember we draw a free body diagram, draw all forces the actor on this object and then re-indicator their directions. Force applied here is in this direction. This direction. So rela in this direction and then ke force applied. Rekasi indicate the horizontal and the vertical component. Generally, a force is at an angle. Recreate the components. Draw a free body diagram. Include those components because this force applied. Include these components. So this is our free body diagram. But gaseka include FG parallel. This is because this object here up the incline. This question calculate frictional force. But ngashumishe this formula ya coefficient of friction because on this statement asbarfa coefficient of friction. Kitlo shumisha the Fnet formula. Arela ore kitlo re Fnet ilegana le MA. Get this Fnet is very all forces. But now let's see for Fnet or substitute again. Substitute the forces still already parallel to the direction of motion. This is our surface. And then ronyaka the forces still already parallel to this surface. Ki FH and then ki frictional force and then lay FG parallel. This FH remember here in this direction. Here over positive. But the friction and FG parallel they over negative. So now let's substitute. FH and then got minus FG parallel and then minus friction equal to MA. But lemoga arne F horizontal. So first create F horizontal. Shumisha this right angle triangle because only F horizontal. And then Roshumisha this angle because this angle equally between this force and the horizontal. Rakashumisha this angle. So now Roshumisha a trig ratio. Kitlore cos theta elegantly adjacent over hypotenuse. But our adjacent in this case is FH and then hypotenuse is 600. So FH elegantly cos theta and then Roshumisha this angle which is 20 degrees and then times 600. Erfaure 563.185. So now because Rnali F horizontal, erelaure re substitute here. Then now we create FG parallel. So FG parallel eleganally mg sin theta. Remember for FG parallel ki yaw actor in this direction. So it's amayali this 30 degrees. It's amayali this 20 degrees. And then now erfaure ke 245. So now we're going to create the friction. F horizontal create 563.815 and then FG parallel create 245 and then minus friction. Mass ke 50 and then ba file gore acceleration ke 4.62. So now let's solve for frictional force. I can say a ke nyako e rounda off, ke tlo dira in this way, ke tlo re 563.815 minus 245, and then ka tšea this part ka itlisha on the left hand side, re la gore ke na le minus 50 and then 4.62 e lekana le a frictional force. Ke tlo tšea this friction ka isha to the other side ya ba positive. So now ge o ka pressa this part ka calculator e tlo fa gore re na le 87.82 newtons. So this is our frictional force. Are lebelle the next problem. This one re calculate the normal force. Now lemoge something. Remember our previous discussed gore this object in this direction and in this direction, these forces are balanced. But now more another force is going in this direction. This component here FV leona ia upwards. So these forces dilikana le this force. And then remember this one ke FG perpendicular. So in short I will say Fn plus Fv elegana le FG perpendicular. These forces are balanced. This is Fn. Fn plus Fv dilakana le this force. So now our Fn ke tlo re Fn elegana le Fg perpendicular and then minus Fv. And ra tseba gore Fg perpendicular elegana le mg cos theta. And then Fv, remember gore ke component re tlo create by using the trig ratio. This is sin theta elegana le opposite and then over hypotenuse. So Fv elegana le sin theta and then times 600. So mo ke tlo re sin theta times 600. So now let's substitute. And then angle rena ke 30 degrees. This angle re shumisha only ge re nyaka go calculate these components. Ga re shumishe ge re calculate FG parallel or MG perpendicular. So anyway, our Fn it will fa gore ke 219.14 newtons. So this is our normal force. Are lebelle the last one. This one we calculate the coefficient of kinetic friction. Now it's very easy because the friction. So re get coefficient of friction and then times normal force. This one ona ke 87.82 and then now the coefficient. Normal force ona re calculate le on bjalo ke 219.14. So now because the coefficient of friction, I will divide both sides of this one and then it will be 0.4. So this is our answer. So it's not difficult. The only thing in this object is at an angle, so you create the components, and then the moment you create the components, find the normal force, ro focus on these forces, and then ra re di lekana le this FG perpendicular. So that's it for this problem, and that's it for this tutorial.